The characteristics of the plenum, hods, and their interactions have been used to derive the STOE photon diffraction model. Experiment confirmed the model by predicting and not rejecting the STOE model of diffraction experiments. See the Hodge Experiment, its STOE photon diffraction video here. This video extends the STOE model of photons to model inertia. The Newtonian model recognizing two vectors of mass. Inertial mass is the proportionality constants in the mapping of a body's measurement of acceleration to a mapping of inertial force. Force equals ma. Gravitational mass is the body's measurable characteristic effect on the plenum density at some point in space from the mass, in accordance with G times m divided by r. The divergence of the plenum density is the gravitational force that acts on the surface area of the hods of the target mass. The transform forces are then combined and inverse transformed to determine the trajectory of a body. This method requires the equivalence principle, which is the inertial and gravitational effects are proportional. The problem is that the equivalence principle relates fundamental characteristics of matter, but seems to have no more fundamental principle about the characteristics of the universe than this necessity to make a Newtonian method work. The STOE expanded on the Hod-plenum interaction and particle formation by describing the photon and positing the interaction of the hods and plenum. Another force to dampen sideways movement was necessary to prevent the hod from achieving a velocity of light perpendicular to its forward motion. The dampening model was of a non-turbulent flow. Another aspect of the Hodge experiment was in the simulation. The simulation calculated the photon induced a wave in the plenum, which became like the pilot wave of the quantum mechanical Bohm interpretation. The problem with the Bohm interpretation was, of course, that it didn't know the source of the pilot wave. Here we're identifying the source of the pilot wave. A wave in the space of general relativity is also assumed in other models. The universe has been assumed to derive from a source where plenum and hods go from a source to a sink. The plenum density varies as 1 over r from a source or sink in the heat equation, like gravitational mass. The wave equation was a critical part in the Hodge diffraction experiment simulation. The photon's movement induced a wave in the plenum. This wave traveled much faster than the photon and was reflected from matter particles. Consider what a wave is. Here we have one application of the wave equation, which is a pendulum. The bob is swung from its neutral position to some higher point where this has maximum potential and minimum velocity. The sidewards motion is described by the wave equation. It's a sinusoidal motion. This position of the bob is also the rest position. The swing is continued from here up in this direction and is continued by inertia. Here we have minimum potential and maximum velocity. If the wave equation applies, the motion is described by a sine or a cosine function. This requires some of the motion to be totally dependent on inertia, and thus we then can define what inertia is. The photon diffraction experiment uses the convolution of the heat equation and the wave equation to achieve the successful result. The medium of the wave in the Hodge experiment was the massless plenum. Remember that mass, meaning gravitational mass, was carried in the hods. Therefore, the plenum is the carrier of the inertial mass. The hods are the carrier of the gravitational mass. In general relativity, this would mean that the space of general relativity is the carrier of the inertia in our world. The equivalence principle follows from the capture of the same amount of plenum per hod. The equivalence principle is derived rather than having to be assumed. That a wave is carried by the plenum is also indicated by the entanglement of quantum mechanics. Wave resonance characteristics and a much faster than light speed.